Hello everyone, welcome back to my Journey Education YouTube channel. So, today we are going to explore a fundamental concept in software engineering that powers everything from fast database searches to secure password storage. So, our topic is hashing algorithms simplified. Whether you are a student or a developer, understanding this will significantly improve your technical knowledge. First, let's look at the overview. Hashing algorithms are absolutely crucial for efficient data storage and retrieval. In computing, we often deal with massive amounts of data, and searching through them one by one is simply too slow. Hashing enhances performance across various applications by providing a much faster way to find what we need. The primary role of hashing is to make data access instantaneous instead of scanning an entire list. Hashing allows us to jump directly to the data's location. This rule is what makes high performance software possible today. Here is our agenda for the rest of the video. We will cover the definition and purpose, move on to the core concept like keys and values, discuss hash table operations, and then tackle the very important topic of collisions and chaining. Finally, we will wrap up with practical examples and summarize. Now, let's explore the how. We will look at the three pillars of this system. The hash function, the key and the value, these are the individual parts that make the whole system work together seamlessly. The hash function is the engine. It's a mathematical formula that maps input keys to specific indices. In a data structure, it takes your input, no matter how large, and turns it into a fixed size number that represents a specific spot in memory. Next, we have keys. Keys serve as distinct identifiers. Think of them as a student ID, username, or a product barcode. These are the unique pieces of info we use to find the associated data within the hash table. And what are we actually looking for? Those are the values. Values are the essential data elements linked to the keys. For a student ID, the value might be the student's entire profile, including their name, grade, and the address. Not all hash functions are created equal. A good hash function must be deterministic, meaning the same input always produces the exact same output every time. If it gave different results for the same key, we would never find our data. Let's look at the structure. Hash tables typically use an array-based structure. The identities of this array are the outputs of our hash function. This allows us to store key value pairs very efficiently. How do we put data in? During insertion, we compute the hash value for a key and store the key value pair at that specific index. It's a straightforward process that happens in a fraction of a second. Getting data back is just as easy. To retrieve a value, you simply compute its hash again using the same function. This gives you the index and you access the value directly at that spot. No searching required. Let's look at a simple example. If we take the key John and the hash is 5, we put John data in slot 5. Later, when he wants John's info, we hash John again, get 5 and find it instantly. Now, we must face a reality called a collision. This happens when two different keys produce the exact same hash index. Since a table slot can usually only hold one item, we need effective resolution techniques to ensure we don't lose data. One of the best ways to handle this is chaining. In chaining, instead of storing just one item at an index, we store a linked list of entires. If a collision oc- occurs, we simply add the new entry to the end of the list at the index. This ensures data integrity even when keys overlap. Now, let's look at a practical step-by-step example of how we build a hash table using chaining. Imagine we have an empty hash table with 10 slots. Our hash function is simple. First entry, we want to insert the key 22 with a value is apple. The hash function gives us we go to index 2 and store apple. Second entry, we insert key 35 with value is banana. We store banana at index 5. The collision. Now we want to insert 42 with value cherry. But wait, index 2 is already occupied by apple. The chaining solution. Instead of searching for a new empty spot, we simply treat index 2 as the head of a linked list. We chain the new data. So index 2 now points to apple and apple points to cherry. As we add more keys like 52 or 62, this chain at index 2 grows longer. This visual representation shows how chaining allows the hash table to grow dynamically without running out of space at a specific index. Once the data is stored using chains, how do we get it back? The retrieval process is a two-step journey. Step 1. Locate the bucket. Suppose we want to find the value for key 42. We run the bash function again. This tells us immediately to ignore indices 0 and 1 and 3 enough 9. We jump straight to the bucket it at index 2. Step 2. Traverse the chain. Once at index 2, we see a list. We start at the head. The first item is 22, apple. That's not our key. We move to the next link in the chain, finding the match. The next item is 42, cherry. We have found our match. We retire cherry and exit the process. Even though we had to look through a small list, it is still incredibly fast because the hash function narrowed our search down from the entire database to just one specific chain. To wrap up, hashing is a vital tool for performance and data management in modern computing. We covered everything from basic functions to complex collision handling. I hope this was helpful. For more learning, check out online coding exercises. As we move toward the conclusion, let's recap the most vital takeaways from this session. The core mechanism. Remember that hashing is the synergy between keys, values, and the hash function. Efficiency is king. The primary goal of any hashing implementation is to minimize search time and maximize the speed of data retrieval. Collision handling. No hash function is perfect. A collision is not an error. It is a natural occurrence that we must handle gracefully using traits like chaining to maintain data integrity. Deterministic nature. Always ensure your function is deterministic. If the same key results in different indices at different times, your data retrieval system will fail. To conclude our technical discussion, let's reflect on why hashing is the backbone of modern software development. Scalability. In a small list, searching is easy, but in a database with a billion users, only hashing can provide the speed required. to log in or search for a profile in real time. Resource optimization. By reducing search times, we reduce the CPU load on our servers, making our software more cost effective and environmentally friendly. Data integrity. Hashing doesn't just store data, it organizes it. By using keys and values correctly, we ensure that the data we enter is exactly what we stored without occupation or loss. Professional stand. Whether you are building a web app or high security cryptographic tool, mastering hashing is a professional requirement for any high level developer. So, this is the content of my video. If you have any questions about this topic, drop into the comments below. So, see you again with another new video. Thank you very much.